Division of whole numbers. Addition and subtraction are inverse operations. Inverse operations undo each other. Consider adding and subtracting 2. If I start out with 7 blocks, and I subtract 2, I now have 5 blocks. If I add 2 to those 5 blocks, I have my 7 blocks again. Subtracting and adding back the same amount results in no change. What about if I start with my 7 blocks and I add 2 to it? I now have 9 blocks. But if I subtract off 2, because 7 plus 2 is equal to 9, but now I want 9 minus 2, I'm back to my 7 blocks. What do we see? Adding and subtracting off the same amount results in no change. Division as repeated subtraction. Consider 6 divided by 2 is equal to 3. 6 is the dividend, 2 is the divisor, and 3 is the quotient. If I have $6 and tickets cost $2, how many tickets can I afford? 3 tickets. You may think of division as making as many equal portions of a particular size as possible. In the case of our tickets, we want to make equal portions of $2. How does this work? Well, I'm going to let each block represent $1. So I have 6 blocks, I have $6. And I want to subtract 2 repeatedly. So $6 minus $2 is equal to $4. And I can see that I have $4 here. And $4 minus $2 is equal to $2. I have $2 there. And $2 minus $2 leaves me with $0. This is an example of repeated subtraction. More quickly, 6 divided by 2 is equal to 3. Multiplication can be thought of as repeated addition. So if I want 3 times 2, I can really think about this as 2 plus 2 plus 2. And I can see that I have 6. So 3 times 2 is equal to 6. Division can be thought of as repeated subtraction. So if I have my 6 and I can subtract 2, I have 4 left and I can subtract another 2. And I have 2 left. And now I can subtract the last 2. And I have 0 left but I can see that I have 3 groups of 2. So 6 divided by 2 is equal to 3. We can think about division as splitting into equal groups. I have $6 that I want to give to 2 children equally. How much does each child get? Pretend that each dollar is a unit. So $6 means that we have 6 units. Since each child gets the same amount, and we have 2 children, we can arrange the units into a rectangle with one side being 2. So here I have a rectangle with one side that's equal to 2. The other side will give us the answer. So when I arrange this rectangle, where one side is 2, I can see that the other side is 3. So each child gets 3 units or $3. Notice that finding the answer this way did not use subtraction. Did the rectangle make you think of the area model of multiplication? Multiplication and division are inverse operations. Consider multiplying and dividing by 2. If I have 6 and I want to divide it by 2, here's my 6. I'm going to put it into groups, my blocks into groups of 2. So I can see that I have 3 groups of 2. So because 6 divided by 2 is 3. But now I want to multiply this by 2, the 3 by 2. So let's put this back together. And we're just moving the blocks. And now I have 3 times 2, which is equal to 6. Dividing by 2 and then multiplying by 2 results in no change. What happens if we have 6 and we multiply that by 2 and then divide by 2? So let's multiply our 6 by 2 and create another column of 6 next to the one we have. And I can see now that I have 12 blocks. I need to divide my 12 by 2. So let's divide this into groups of 2. And I can see that I have 6 groups of 2. So 12 divided by 2 is equal to 6. Multiplying by 2 and then dividing by 2 result in no change. Done in either order, multiplying and dividing by the same number other than 0 undo each other. Multiplication and division are inverse operations. We know that addition and subtraction are inverse operations. Division can be thought of as repeated subtraction. Because addition is the inverse operation for subtraction, repeated subtraction can be undone by repeated addition. But repeated addition is another way to think about multiplication. Since repeated addition can undo repeated subtraction, multiplication can undo division. Multiplication and division are inverse operations. Is there a quicker way to divide than repeatedly subtracting the divisor? Thank you for watching.